Hello class, today we're going to learn about the cosine law. In particular, we're going to learn about the cosine law and how we can determine a side length. So let's go back to when we were just learning about trig ratios, the sine ratio, the cosine ratio, and the tangent ratios. Now these ratios can only be used on triangles that have a right angle triangle, so something like this, okay? So without that right angle triangle, we cannot use the trig ratios. That's the sine ratio, the cosine ratio, or the tangent ratio. Last class, I taught you about the sine law. And this one is applicable to triangles that are not right angle triangles. And in this case, you would have at least one pair. So you need at least one angle and one side length in order for us to use that law. So here it is, the sine law. And so remember, we need at least one pairing in order to use it. And then you just need one other side or angle. So if you had the side B, then you can solve for the angle B. Okay, so then we can solve for that. Or vice versa. If we had the angle B, then we would have to solve for the side length of B. And the same goes with the other pairing of side C or the angle C. Okay, so sine law can only be used on triangles that have side angle or angle side. And in both cases, like we mentioned, you must have an angle and side pair in order to use that law. So now we have to ask ourselves about the questions where are not right angle triangles and we do not have a pair. So this is where the next trig law comes into play, which is the cosine law. And the cosine law, just like in sine law, has two formats. Again, you don't have to memorize both formulas, you just have to know how one turns into the other. So in cosine law, the side length version of this is c squared equals a squared plus b squared minus 2 times a times b times the cos of the angle C. So now if we look at the triangle, here's a triangle ABC. These are small c's, small a's, and small b's. So that means in cosine law, we need side lengths. So side length C is over here, and that's the one you're looking for maybe. But then therefore you're given side length A and B. So you must be given two side lengths. And again, they are also in the equation here. And then those two side lengths, the angle between them must also be given, this one here. And that angle is the angle across from the side length you want. Okay? So we want this side length C, and to solve for it, you must have the other two side lengths and the angle between them. Okay? We don't have a pair, unlike sine law. The pair in sine law required the matching side and angle to be already known. But in this case, we don't. We just have the two side lengths and the angle between them. And therefore, we can use this formula. And that's the one we're going to focus on for today. The next class, I'll teach you the angle version. So when can cosine be used? Cosine law can be used when you know three sides, because we can also figure out the angle, but that's for next class. Or when you know two sides, like this A and B, and the angle between them is a must, okay? You must have the angle between them. So here it is again. I think we are understanding that the lettering, though, that I used here, the c squared equals a squared plus b squared minus 2 times a times b times cos of c, it can be rewritten. If in case you wanted to solve for the side length A, for example, and you had the angle A, and you already have the side C and the side B, then that is allowed. So you can actually rewrite it and say, I want to solve for my side length A, which I don't know. Okay? How it would be rewritten is just that what matters the most is that if A is the one we don't know, A will be written on the left side of the equation. So a squared equals, and then you write the two side lengths you do know. So b squared plus c squared minus 2BC. Again, remember, it's the side lengths that we know are written on the right side. And then we do the cos of the angle we have, which is the angle across from the side length we want. So again, you can rewrite this formula many different ways, but what matters is that the side length that you're looking for is the left side of the equation, okay? And the angle across from that side length is known. All right, let's try a question to help you maybe clarify this law out. So here's example 1. In an acute triangle, DEF, so I'm going to draw my triangle DEF. DEF, the capital letters are my angles. I know side D. So that's going to be across from the angle D. So D equals 4.9 centimeters. Then I also know the side length F, which is across from angle F. So that's 6.2 centimeters. And I know the angle E. So angle E is over here, and that's 64 degrees. Without finishing reading the sentence, I know that I'm going to end up looking for the side length E, okay? Because given based on what they've given me, I must have the two side lengths known, and the angle between them is the angle across from the side length I'm looking for. So I'm going to rewrite the cosine law using E on the left side. So E squared equals D squared plus F squared minus 2DF, so times D times F, times the cos of the angle E. Remember, these two must match. The side length I want, I must know the angle across from it. So filling in what I have, I'm just going to rewrite it with all the numbers I have. So D was 4.9 squared, F was 6.2 squared, minus 2 times 4.9 times 6.2 times the cos of the angle, which is 64 degrees. And with cosine law, as with most of the trigonometry, you want to just punch this all right into your calculator and do this in one go from left to right, making sure you put the right symbols in the right spots. And remember that this is a multiplication between these values here, okay? And it will do the rest for you. This gives me a value of 35.8145691, still approximated because the calculator only showed me a certain amount of decimals. But this doesn't actually give me the side length E like I wanted. Look at the equation. It gives me the side length of E squared. That's the value that's written here. So in order to solve for E, well, I have to get rid of the squared, which means take the square root of both sides. That will eliminate the squared on the left side. So my answer of the side length of E is approximately 5.98 centimeters. Although this question asked me to the nearest tenth of a centimeter, so really I would say E is approximately 6, because when I round to 1 decimal places, I would have to go one more up. So it's approximately 6 centimeter long. All right, and from there you can probably figure out everything else. So the question actually asked me to solve for the whole triangle, which means I need to solve for all the angles and the side lengths. So I've found out all 3 side lengths. Now I can go and solve for the rest of the angles. How do you solve for the angles when you only have one angle? Well, now that I know what E is, I have E is equal to approximately 6.0 centimeters. I now have a pair. Do you remember what law allows me to solve for other angles if I have a pair? I now have a pair of a side length and an angle. So now using another side length, so for example F, I can now solve for the angle F. So I'm going to write sine law with the angle on the top. So I write sine of capital F over little f equals sine of big E over little e. And I'm going to fill in what I have. So sine of f, which is what I'm looking for, over the side length, which is 6.2, equals sine of the big E, which is 64 degrees, all over little e, which we solved for, which is 6. And then I'm just solving for that side length. And just to recall, that means I want to isolate for that f again, right? So first I got to get rid of this denominator. So I'll multiply both sides by 6.2 and rewrite it. I've got sine of capital F equals, I'm going to write the number first. So 6.2 times sine of 64 degrees divided by 6 centimeters. And then to isolate for what I'm looking for again is just the angle F. So that means I need to get rid of the operation of sine. So I'll do the sine inverse. And what I do to one side, I must do to the other. And the sine inverse always goes in front. So my equation will end up being F equals sine inverse in brackets 6.2 times sine of 64 divided by 6. And then you punch it all into your calculator and you should get make sure you type in 6.2 times the sine of 64 first, divide that by 6, and now take that answer and do the sine inverse of the answer. So you should get approximately, the angle of F is approximately 68 degrees, okay? And now I've solved another value on here. That would be this one here, so that's 68 degrees. And to find the very last side, I can use the sine law again, or if you recognize that all angles in the triangle add up to 180, angle D is therefore just the 180 subtract the two angles you have. So 64 minus 68, and you should get 48 degrees. All right, so when you solve for these triangles, you may have to pull in some information from cosine law, sine law, and the sum of all interior angles, okay? Make sure you try all these problems, and if you have any questions, make sure to ask.